In this video, we will learn how to interpret a station model map for the purposes of locating a front. It is important to note that the map being used has been simplified for general understanding. In order to locate fronts, an understanding of what goes into locating them are needed. Before we do this, please note that when looking at a map, north is always found to the top of the page, and the other directions are located in their respective locations. By knowing this, you will find determining the direction of frontal movement a bit easier to find. There are three ways to locate a front. The first is through an analysis of the temperature values of the station models. What one should look for is a noticeable difference in temperature. In most cases, we are only looking at a few degrees of change, but even a subtle change is enough to determine the location of the front. Looking at our map, we can see on the left there are lower temperatures than those on the right. The temperatures under 50 degrees are one grouping, and those over 50 are another, which allows us to draw a line between the station models to locate the front. We will leave the red frontal line for the next interpretation. The second way to locate a front is to interpret the dew point temperatures. On opposite sides of the front line, one will find differences in dew points. Just like with air temperature, we will see very subtle changes, but those are enough to help place the front line. Looking at the dew point temperatures, we can see that on the left we have dew points around 30 degrees, but to the right we have values near 50 degrees. Using this difference in values, we can place the front line between the clear difference in dew point values. We will leave the green frontal line for the next interpretation. The final step in locating a front is to look at the wind patterns in the area. A sudden shift in wind direction is usually indicative of a front passing through a region. This is again shown to be a clear left side, right side map difference. Using this difference in direction, we can place the front line between the clear shift in wind direction. We will leave the blue frontal line for the next interpretation. Now that we have used all three methods to identify potential front locations, we can begin to see a trend in the location of the front. Outside of the temperature line moving further out to the left, they all occur in the same location. With this being said, we can make the assumption that the temperature at the center station model should be clustered with the temperatures to the left of the frontal line. With this being known, we can now determine our final frontal location. So we have our front located. What now? We now have to determine what type of front we have. For the purpose of this discussion, we will only include the option of a cold or warm front, as occluded and stationary fronts would not apply in situations such as this one. Now the question is, how do I make the determination of which front I have? To answer this question, you have to analyze the moisture, temperature, and wind properties. For moisture, warm fronts always have moister air behind the frontal line, and cold fronts have them in front of the frontal line. For temperature, warm fronts always have warmer air behind the frontal line, and cold fronts have warmer air preceding the frontal line. Finally, wind directions behind a warm front are typically southerly, which a cold front has westerly winds behind the frontal line. With these being identified, we can apply it to this map. Behind our front line, we have lower temperatures, drier dew point temperatures, and westerly winds. All these items combined identify this front as being a cold front. The final item to determine now is in which direction is the front moving. To determine this one must understand the principles of wind and how to interpret the wind barbs of a station model. In meteorology, wind is not denoted by where it is going, but instead is denoted by where it is coming from. An easy way to interpret this is to treat the wind barb as the end of an arrow and then add an arrowhead to the other side of the station model. The resulting arrow identifies where the wind is blowing to based on the direction the arrow is pointing and where it is coming from. By doing this to all the station models, we can identify the primary direction of the wind is blowing towards. From this, we can clearly state the front is moving towards the east or southeast. In summary, in this video we have learned how to identify the location of a front and to determine the direction it is moving. The key items to remember about locating fronts is that you must look at temperatures, dew point temperatures, and wind to locate a front. By only using one of the three, you can get a good idea of the type of front you have, but to ensure you have it correct, be sure to include all three. Please feel free to share your comments and questions with your instructor regarding the content of this video, as well as to receive further guidance on the concepts covered.